Okay, this is a review of solving quadratic equations by the square root property. So I'm just going to give about 5 examples of using that property to solve a few different types of quadratics. This first one here, we have x squared equaling 169, and we know in order to undo squaring, we can introduce a square root, so that's going to be our first step here. And the square root of x squared, of course, just comes out as our value of x. When we square root 169, we really have plus or minus 13. If you like, you can consider it this way. A positive 13 times a positive 13 would give back a 169, as would a negative 13 times a negative 13. So we get two answers, and you can express your solution either in this first way, or if you like, you can break it up to solution set notation. So either of those ways of expressing the solution would be appropriate there. Another similar example, now we have x squared minus 17 equaling 0. And again, we're trying to isolate the squared term, so I'll just start by adding 17 to both sides. And now I have the x squared term alone on the left. So we will square root both sides to get x by itself. And here we have x equaling plus or minus the square root of 17. In this case, the square root of 17 does not simplify, therefore this would be our solution. And again, another way of writing that would be in solution set form as the negative square root of 17 and the positive square root of 17. So any quadratic equation still has two solutions. They always do. And then another one here, again, we're trying to get the squared term alone. So in this example, I'm going to do a few steps to make that happen. I'll start by adding 120 to both sides. And then after that, we're going to divide both sides by 6 to get the x squared term alone. At this point, it should look very similar to our first example. So we know to undo the squaring, we will square root both sides. And we will have plus or minus the square root of 20. But that does simplify, so we should. Just a reminder, out on the side here, I'll make a little factor tree for 20 in case it helps. 20 is 2 times 10. 10 is 2 times 5. So the factors of 20 are 2, 2, and 5. Therefore, it can be simplified as plus or minus 2 square root of 5, because we had that pair of 2's there. And the solution set notation here could be negative 2 square root of 5 and positive 2 square root of 5. So those would be our two solutions here. The next two are a little bit different in form. Again, though, it's just is something squared on one side, and yes, it is. So immediately we're going to square root here, although it might look a little different to you. If I square root both sides, the x minus 7 term will pop out because we square rooted something being squared. On the right hand side, we have a perfect square, so we get our plus or minus 5 out of that side. So to keep isolating x, we'll add 7 both sides. And I'm going to write it this way, x is equal to 7 plus or minus 5. That really breaks down to two solutions though. We either have a 7 plus 5 giving us 12, or 7 minus 5 giving us 2. So in this case, because my radical simplified, I was able to take my solutions down to kind of a cleaner form, and the solution set here would just be 2, 12. Okay. Final example will be very similar to this one. We have a quantity being squared, so we'll start by undoing that by square rooting. And that pops out our 3x plus 1 on the left. Thinking briefly about 21 under the radical, the only factors of 21 are 3 and 7. So no perfect squares over there, so I'm just going to say plus or minus the square root of 21. And I have two steps to get x alone. I'll start by subtracting 1. to have now 3x is equal to -1 plus or minus the square root of 21. It's nice to put the radical at the end. And then we'll just do our final step by dividing both sides by 3. So here we could have x is equal to -1 plus or minus the square root of 21 all over 3. And that would be final solution there. In solution set notation, it would just be broken up as two values. So I'll just go ahead and show that in case you're interested. It would be a -1 minus root 21 divided by 3, and a -1 plus root 21 all over 3. And that would be it. So hopefully this helps clarify using the square root property, a few examples, and that's it for now.